For number 5 from 4.2, we are looking at the mean value theorem. So it says, verify that the function satisfies the hypotheses of the mean value theorem on the given interval, then find all numbers C that satisfy the conclusion of the mean value theorem. So Rolle's theorem was looking for where the tangent line is horizontal. The mean value theorem is very closely related. It's going to give you an interval, and you really find the secant line of those endpoints of the interval. And the mean value theorem tells you where the tangent line is parallel to that secant line formed by your endpoints. So kind of a lot going on here. The main application is used in many mathematical proofs. So my first step here is to really say that is f continuous on the interval. And because it's a polynomial, f is defined and continuous. On the interval. The second point is f is differentiable on the interval. So I do need to take the derivative. So f prime of x is equal to 6x squared minus 3. And this is defined everywhere. This is not undefined anywhere. Or if you want to say it's defined everywhere. So we can use the mean value theorem. And a lot of people abbreviate it as MVT. So the mean value theorem, you'll see at the box that it says, then there's a number C in A to B such that f prime of C is equal to f of B minus f of A over B minus A. So we need to know A, B, f of A, and f of B. So those four values we need to know. So A is equal to negative 2, B is equal to 2, f of A, or f of negative 2, is equal to negative 9, and f of 2 is equal to 11. So using the MVT, which again is f of B minus f of A all over B minus A, I have my f prime of C is equal to 11 minus a minus 9 all over 2 minus a minus 2. So this is going to be equal to 5. So you could say that f prime of C is equal to 5. So this is the mean value theorem value. So what that means is this is where we're trying to find where the tangent line, or lines, there could be more than one, are parallel to the secant line, or where is the derivative equal to 5. So let me write that down. Still getting used to this app. Trying to get a new stylus as well. Anyway, so we want to really set the derivative equal to the mean value theorem value that we just found. So this is going to be 6x squared minus 3 is equal to 5. And then if I add 3 and divide by 6, so then x squared is going to be equal to 8 over 6, or x squared is equal to 4 over 3. Then x is equal to, if you take the square root of both sides, plus or minus square root of 4 over square root of 3, which is equal to plus or minus 2 over square root of 3, which then, if we rationalize that, it's going to be 2 square root of 3 over 3. That would be the exact answer, and then that's approximately plus or minus 1.15. So on the worksheet, you'll notice that there's a graph there which kind of shows that at negative 1.15 and at 1.15, the slope of those tangent lines is equal to 5. And that's the same as, or that's parallel to, the slope of the secant line that's in between the original negative 2 and 2. So that's really the main point of the mean value theorem, is that we're saying where are the tangent lines parallel to that secant line formed by the original interval.